That equation examples are what we are going to see in this lesson. We have seen now the introduction in the last lesson. Now we are going to see more of quadratic equations. How do we handle more questions about quadratic equations? Now, here the question is, the roots of the equation x squared plus this are alpha and alpha minus 1. Find the values of q. Now, if they give you an equation with quadratic equations, what you do, you first get the sum of the roots and also get the product of the roots. But you know that from the formula we saw in the last lesson, we said that the sum of the roots is equal to negative b over a, then the product is c over a. We said the general equation of a quadratic is this, so we compare and get the values of a, b, and c. So from here, if you compare, so that now our a is 1, the quotient of x squared, here is 1, here is a. So, our b, if we compare here, is 6, and our c, if we compare, is q. Now, the roots they are giving me are this and this. So, the roots are alpha minus 1. So, I get their sum. So, when I sum these two, I'll be adding. So, the sum will be alpha plus alpha minus 1. And all of this, we say the sum of the roots. These are the roots. Their sum is always given by negative b over a. So the sum here, so I get 2 alpha minus 1 equal to my negative, then my b, here is 6 over a. My ac is a 1. So if I take this aside, start from here, my 2 alpha will be, when I take this side, it's going to be negative 6 plus 1, which will be negative 5. Imply that my alpha divided by 2, negative 5 over 2. Then I also come and I get the product. So the product is going to be alpha, the product of these two roots, which will be, we say that the product is always c over a. What is now my c? You can see from here, my c is q over a, which is 1. So the product there is that now, I draw this here, I have alpha into alpha minus 1 equal to q. Now, I want us to get the value of q. We know the value now of alpha. You know that alpha is here, so substitute here alpha from here. So my alpha is going to be now negative 5 over 2 into now negative 5 equaling q. This will be negative 5 over 2 in the brackets. Here when you cross multiply, this will give us negative 2 plus negative 5, which will be negative 7 over 2 equaling to q. And we multiply negative give us positive. 5 times 7, that is 35. 2 times 2, that is 4. And so we have the value of q. How are we substituting? You know that from here, our alpha is negative 5 over 2 from here. Okay, let us see now how we have this. Find the equation with integral coefficients whose roots are x squared, squares of the roots of the equation, this. Now the equation we want to get, the roots of that equation we want to get are squares of the roots of this equation. So what we start with to get the roots of this equation? But I don't know them. So I'm going to say, let alpha and beta be the roots. You can say alpha and mu and the beta, it's up to you. But because we use these are the common, so let alpha and beta be the roots of this equation. It means that now, from here, if we compare with the general, from this equation, we compare now, our a here is 2, our b is a 5, and our c is negative 6. So now, these are my roots. So my roots are alpha or my beta. So I need their sum. I come here and I get their sum. So the sum will be alpha plus beta. But we say the sum is always given by negative b over a. So this will be my alpha plus beta is C, negative B. So I have negative into a 5 over A, which is a 2. So that's my alpha plus beta. Then the product of those roots, instead when I get the product of these two roots, I'll get multiply the alpha times beta, which will give us alpha beta is C over A. So from the product of roots. So our C is negative 6 over 2, which is A. And so this is going to give us negative 3. So now I have the sum of the roots of this. Now I need the equation. So they're telling me that if the roots are this, the equation, the one I want to get, its roots are going to be the squares of this. So the new roots are the squares of the roots of this equation. So if the roots of this equation are this, then the equation I want to get, its roots are squares of these ones. So the squares are going to be alpha squared over beta squared. You see that these are squares of these ones. So we come for our new sum. So the new sum of roots, these ones, is alpha squared. We sum them. And remember we saw that whenever we have this, we always express it in terms of a sum and the product using the symmetric equations we saw. So this one is alpha plus beta squared minus 2 alpha beta. So in the substitute here, my alpha plus beta, you always express it in this form because the sum, you have it already for these ones, which is negative 5 over 2 squared minus 2 into alpha beta is negative 3. So this will give you, when you square this, you get 25. When you square 2, you get 4. Minus to give you a positive, then plus 6. When you cross multiply, we add 49 over 4. You simplify that. Then I come to my new product, which will be alpha squared and beta squared. You multiply these two, which will be alpha beta. Because they are in the same square and in the same power, and then multiplying, you can easily take out that power. Now we have alpha beta here as negative 3, the whole square, which will give us a 9. Now we come to the general equation. So x squared minus sum of roots of the equation we want to get, then plus product of roots will be equal to 0. From here, our x squared. Remember, the equation we want to get sum with these roots. So their sum is 49 over 4 into x. Then their product is 9 equal to 0. So you can multiply it by 4, multiply here by 4, get 4x squared. Multiply here by 4, the 4 will cancel, here with 49x, then plus, multiply here with the 4, get 36. Multiply here with the 4, get 0, and that will be the answer. When you come to this now, the same idea. The roots of the equation is alpha and alpha plus beta. Find the two possible values of p. So the roots we have, we first compare. If I compare, so my a is 1. My b, if I compare, is negative b, and my c is 8. Now, the roots we have are alpha, alpha plus 2. So these are the roots I have for this equation, meaning I have to get their sum first. So when I sum there, these two, sum will be alpha plus 2. But they say the sum of roots is given by negative b over 2. Over a, not 2, over a. So this is negative into our p is now negative b. Our b, this sign is negative from the equation. The whole over a, which is 1, and so this one is going to give us a p. So when I add this one, I get 2 alpha plus 2 equal to p. Can we get the value of alpha? So my alpha here will be p. When I take this side, then I divide by 2. So that will be the value of alpha. Then I come and I get the product of roots. The product, we multiply this and this. So alpha into alpha plus 2. And we say this for C over A. From here, the sum of roots given by C over A. So, instead we have alpha. From here I have already my alpha, which is going to give me P minus 2, the whole over 2. Then I'm substituting this alpha, I'm putting that minus alpha is 2 over 2. And remember, I'm adding a 2 equaling. From here, our C from this question is 8 over A, which is 1, and so this is going to be equaling to 8. So here we can get the LCM. To start here, I'll be adding B minus 2 over 2, A2. The LCM here is going to be 2. So B minus 2 plus 2 times this, I get 4. This is over 1. Then multiply there, I get 2 equaling to 8. So you can easily simplify. This is that we are going to be having. Okay. We are having P minus 2 over 2 into, when we add here we have P plus 2 over 2 equaling to 8. So see, this one is going to give me a 4. And if I multiply through by 4 without, I get multiply here by 4. You know when this is going to be P minus 2 into P plus 2, the whole 2 times 2 is 4, equaling 8. So over 1, I cross multiply. This is the difference of the squares. So I have P squared minus 4 equaling to, when I multiply here, I get that 2. Take 4 this side, so our P squared will be equaling to 2, that's 6. Get a square root, so our P will be plus or minus 6. Plus or minus 6. And those are the values of P. So that's it, members. I wish you